Day 255 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 46, permutations. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. So let's get into it, y'all. Question says, given an array nums of distinct integers, return all possible permutations. You can return the answer in any order. So first thing we need to do is let's look at the definition of permutation. It says a permutation is a permutation is a rearrangement of all the elements of an array. So let's break that down by looking at example 1. In example 1, we have the input nums equals an array of integers 1, 2, and 3. The output is a 2D array of integers. The first one is 1, 2, 3. Second one is 1, 3, 2. Third one is 2, 1, 3. Fourth one is 2, 3, 1. Fifth one is 3, 1, 2. And the last one is 3, 2, 1. So let's break that down by trying to figure out how they got this output from this input, right? And as you can see, in the output is just different permutations or different ways you can rearrange the input, right? So in the input we have 1, 2, 3. So we need to figure out all the different ways that we can rearrange the numbers 1, 2, 3 in any given order, right? So at first you can see we do the ones. We put the 1 first. We have 1, 2, 3. Then we have 1, 3, 2. Then we have 1, 2, 3 and 1, 3, 2 are the only two permutations or only two distinct ways that we can rearrange this output when we put 1 first, right? With 1 as the first integer. Then we do the same thing when we put 2 as the first integer, right? So then we go 2, 1, 3 and 2, 3, 1. These are all of the ways we can rearrange these numbers when we put 2 as the first integer. Then we do the same thing for the last integer, which is 3, where we go and we make 3 the first integer, and we go 3, 1, 2 and 3, 2, 1. And those are all of the ways we can rearrange these numbers with 3 being the first integer. And when we put them all together like this, these are all of the ways that we can rearrange these integers, right? We just do it with the 1 first and do those two rearrangement, then we do the 2 first and do those rearrangements, and the 3 first and those rearrangements. So once again, all we want to do is find all of the ways that we can rearrange these numbers in different orders. Now let's look at example 2 where it might be a little tricky, but it's not really tricky. It actually seems a little easier, right? So in example 2, we have the input nums equals 0, an array of integers 0 and 1. The output is a 2D array of integers 0 and 1. Second array is 1 and 0. As you can see, these are the only two ways that we can rearrange these numbers. We could put the 0 first and then it goes 1. Then we could put the 1 first and then it goes 0. Since it's only two numbers, there's only two ways that we can rearrange it so that we get all of the permutations. Then same thing in example 3, if we only have one integer, so in this case the input is a array of integers, it's just 1 is the only integer. The output is just 1 because there's only one way you can rearrange one integer, and that's just by keeping it how it is. So now that we understand the question, let's get into the fun part, the actual solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. Then after you do that, go ahead and like, comment, and subscribe. Excuse me, y'all. Now, let's get into the fun part, the actual solution. So the first thing we are going to need to do is we are going to need to create a 2D array for our output that will hold all of the permutations, right? So if you see, the output is in a 2D array. So we need to create that 2D array so that we will be able to work with it and return it in the end. So in order to do that, we're just going to declare a variable called result, and that's what we're going to return at the end for our output. And we're just going to set that to a 2D array of integers like this, right? So this is our 2D array of integers. So square bracket, int, square bracket, and we're just going to set that equal to a blank array so we can initialize it. Now we need to create a helper function that's going to help us with the backtracking. So we're going to use backtracking to solve this problem, and we need to create a helper function for that. So in order to do that, we're going to create a function inside of the main function. We're going to create a helper function. So we're going to say func. We could just call it backtrack. Open up the parentheses, underscore nums, colon. That's going to be an array of integers. Array of integers like that. Then we're going to say comma, underscore path. That is going to be, then we're going to say colon, and that's going to be an array of integers as well, right? So the remaining numbers that can be added to the current path, we're going to use that. We're going to use, that's what we're going to use nums for, and then path is going to be the current permutation that we're constructing. So then we're just going to come outside of these parentheses, and we're going to open up our brackets. Now let's get started. First thing we need to do is create a base case, so if no numbers are left to add, and we have a complete permutation, right? So in order to do that, we could just say if num dot is empty, then we can open up the brackets, and we say result dot append, open up the parentheses, path, just like that. Come outside of those parentheses, and then we're going to say return. Now we need to find a way to iterate through each number in the current nums array. So in order to do that, all we have to do is come outside this if statement, and we're going to say for I in 0 up to nums.count. Boom. We need to create a copy of the current nums. So to do that, we're going to say declare a variable called new nums, and we're just going to set that equal to nums so we can have our copy, which will help us when we are trying to change things and mutate things in the nums array. Then we're going to come down here. We need to remove the current number at index I from the copy. So in order to do that, we're just going to say new nums dot remove, open up the parentheses, we're going to say at, and then we're going to say I for index I. Now we need to add the current number to the path so we can continue. So this is where we're going to use some recursion. We're going to say backtrack, call the backtrack function, and we're just going to open up the parentheses. We're going to say new nums, comma, path, plus, open up a square bracket, nums, square bracket, I, just like so. Then we could come outside of this function, this helper function, and we need to start the backtracking process with a full nums array and an empty path, right? So in order to do that, we're just going to say backtrack, open up the parentheses, nums, comma, square brackets, empty for the empty array. And then we need to return all of the permutations. So in order to do that, we could just say return result, just like that. Because remember, this is the result array right there. So that should be all she wrote, y'all. Let's run it, see how it runs. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays submitted after we accept it, because we all know how this LeetCode stuff can get. Ooh, and look at that. 0 milliseconds beats 100% of users with Swift, y'all. That's what I'm talking about. That's what I'd like to see. Those are some good numbers right there. You know, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.